Good afternoon, guys. What we're going to look at today is starting chapter 7, section 7.1, looking at rational expressions, how to multiply, divide them, as well as how to simplify them. All right, so first what we need to know is what a rational expression is. A rational expression is the quotient of two polynomials. So all that means, just give you some examples here, is we just have two polynomials that are being divided against each other. So x divided by y, 8x squared plus 2 over 4x plus 3, 6y squared plus 8y plus 4 over 3y squared minus 2y plus 5. All right, just any type of polynomials being divided against each other, that's what creates a rational expression. All right, so the first thing we're going to look at is how to simplify and write rational expressions in our lowest terms. So to do that, we're going to use what we call the fundamental property of rational expressions. All right, so the fundamental property of rational expressions. And all this says is that if I have a rational expression, so if I have a over b, and it's a rational number, and if c is any non-zero, okay, so non-zero real number, all right, so if I have a and b, and that's a rational number, and if c is a non-zero real number, then I can say that a over b is equal to a times c over b times c. All right, so that's what the fundamental property tells us. As we go through our examples, you'll see how we apply that, okay? So now let's look at how we write our rational expressions in lowest terms. So we want to write rational expressions in lowest terms. All right, so our first step, or step one, we're going to factor, excuse me, we're going to factor both, excuse me, we're going to factor the numerator and the denominator. All right, so that's our first step. Our second step is to apply the fundamental property. And really, so what all the fundamental property means, it means we just want to cancel out and cross out our common factors with each other. And we'll see that as we start working these problems and go through our steps. All right, so that's our steps on how to write rational expressions in lowest terms. So let's look at an example. All right, so we want to write a squared minus a minus 6 over a squared plus 5a plus 6. We want to write this expression, this rational expression, in lowest terms. Well, our first step tells me to factor the numerator and the denominator. All right, well, the numerator is going to factor into a minus 3 and a plus 2. Remember what we're looking for. We're looking for two numbers that multiply to give me a negative 6, but add to give me a negative 1. And on the bottom, we're looking for two numbers that multiply to give me a positive 6 and add to give me a positive 5. So we have a plus 2 and a plus 3. All right, so now this is how, that's step one, factoring the numerator and denominator. Now, step two, applying the fundamental property, all it says is if we have common factors, well, we can cross them out. Okay, so if we cross out the c's, well, they would still be equal to each other. All right, so do we have common factors? Yes. A plus 2 and a plus 2 cancel out. And so we're left with a minus 3 on the top over a plus 3 on the bottom. Now that's our rational expression in lowest terms. All right, so let's look at another. All right, and in order to do these problems, we need to be very sufficient in our factoring. Okay, so you need to be good at factoring. All right, so let's look at this one. Well, right away, I should be able to notice that this right here is a difference of cubes. So that's x cubed minus 3 cubed. So that factors into x minus 3 times x squared plus 3x plus 9 all over x minus 3. All right, so that's step one. Step two, we divide out any common factors. So x3 and x3 are gone, and we're just left with x squared plus 3x plus 9. And that's our rational expression in lowest terms. All right, very good. All right, so now I want to give you one to try. So you got y squared plus 2y minus 3 over y squared minus 3y plus 2. All right, so pause the video, give yourself a couple of minutes to see if you can figure out how to write this rational expression in its lowest terms. All right, so hopefully now you'll be able to write this in lowest terms. To check your answer, let's look at it together. First, we got to factor the top. So that factors into y plus 3 times y minus 1. The bottom factors y minus 1 and y minus 2. All right, remember, two numbers multiplied to give me negative 3, add to give me 2, 3 and negative 1. Two numbers that multiply to give me 2, add to give me negative 3, negative 1, negative 2. We have y minus 1's in common. Divide those away, we're left with y plus 3 over y minus 2. All right, very good. Now just let me make one note when simplifying these. It's about opposites. Okay, so when we see opposites, so if we have m minus 1 over 1 minus n. All right, well, right away we see some similarities, so we might just try to cancel them off, but we can't because they're not exactly the same. Here we have a positive m minus 1, and here I have a positive 1 minus n. So they're not the exact same, but what they are, they're opposites. This m is positive, this m is negative. This 1 is negative, this 1 is positive. The way we simplify opposites are, opposites cancel out to give you a negative 1. So anytime you see opposites in your problem, you can simplify those to give you a negative 1. All right, so just keep that in mind as we move forward. Because now we're going to look at how to multiply them and then how to divide. All right, so we want to multiply 5p minus 5 over p times 3p squared over 10p minus 10. All right, so our first step is we want to factor as much as we can. All right, so over here I'm going to factor this out first, pull out a 5. That leaves me with 5 times p minus 1 over p. I can't factor the top, but I can factor the bottom, pull out a 10, and that leaves me with p minus 1. All right, well now we can cross simplify. So my p minus 1's cancel. This p cancels with one of these p's, and my 5 becomes a 1, my 10 becomes 2. All right, so we did a lot of simplifying there. Now the only thing we have left is just to multiply our fractions together. So I have 1 times 3p, which is just 3p, over, well, a 1 here times 2, which is just 2. So when we multiply those together, they simplify to 3p over 2. All right, let's try one more of those. Again, we're looking to multiply. We have k squared plus 2k minus 15 over k squared minus 4k plus 3. All right, now times, we have k squared minus k over k squared plus k minus 20. All right, so we want to try to factor and then multiply this rational expression together. All right, so let's factor everything first. So this is why you need to be really good at factoring. So here I have k, what would that be? K plus 5 times k minus 3 over k minus 1 times k minus 3 times, well, up top they have a k in common, so that leaves me with k times k minus 1, and on the bottom I get k plus 5 times k minus 4. All right, again, so a lot of factoring there. And now we just want to cancel out, cross out our common factors. So I have a k plus 5 here, cancels with my k plus 5 there. K minus 3, k minus 3, k minus 1, and k minus 1 also cross out. So the only thing we have left when we multiply across is k over k minus 4. Everything else crossed away. So k over k minus 4. All right, one more for you guys to try, and then we'll move to division of rational expressions. So let's multiply x squared plus 2x over x plus 1 times x squared minus 1 over x cubed plus x squared. All right, so again, pause the video, give yourself a couple of minutes to try this problem by yourself, and then we'll come back and look at it together. All right, so hopefully you've had time to work it out, and now let's see how you did. So I'm going to factor everything first, so that's x times x plus 2 over x plus 1 times, this is difference of squares, so remember that's x plus 1 times x minus 1 over x squared times x plus 1. All right, so now let's cross out all of our common factors. So here I have x plus 1 and x plus 1. This one x cancels with one of these x's, and that's all I have that I can cross out. So now we just have to multiply our leftover factors. So over here I have x plus 2 times x minus 1, and we can just leave them like that, over x times x plus 1. And there's our final answer. There's nothing else that we can cross out on that. All right, very good. All right, so that's multiplying. Now let's look at dividing these. All right, so let's say we want to divide t squared minus 9 over t squared plus 4t minus 21. We're going to divide that. T squared minus 2t minus 35 over t squared plus 8t plus 15. All right, so now we're trying to divide rational expressions. But if we notice here, to divide rational expressions, all that is we're dividing fractions. All right, so if we think back of how we divided fractions last time, we used our three little words. In order to divide fractions, we keep, change, flip. All right, keep, change, flip. So remember, what that tells me is I keep the first one the way it is. I change my division to multiplication, and then I flip my second fraction. So now it's t squared plus 8t plus 15 over t squared minus 2t minus 35. And now what we have is just a multiplication problem like we just got done solving. So there's only one step different between dividing and multiplying, and that's keep, change, flip. So now let's try to solve this out. Well, this factors into t plus 3 times t minus 3. On the bottom, I have t plus 7, t minus 3, times, over here we have t plus 5, t plus 3, and on the bottom, I have t minus 7 and t plus 5. So now that's how everything factors. And now remember, in order to multiply, all we have to do is cross out our common factors. So I have a t minus 3 and a t minus 3. I have a t plus 5 and a t plus 5. And that's the only thing I can cancel out. All right, so now we just multiply what's left over. So t plus 3 times t plus 3. Well, that's t plus 3 squared on top over t plus 7, t minus 7. T plus 7 and t minus 7. And there's our final answer. We divided out all the common factors. All right, and so that's how we divide our rational expressions. Remember, there's only one step difference, and that's keep, change, flip. Other than that, it's just like our multiplication problems.